In this screencast, I would like to explain how to analyze a common problem in swing programming, which is long-running tasks on the event dispatch thread. Something's running on the event dispatch thread that's taking too much time. It unfavorably impacts user experience. The user interface becomes unresponsive, and these things should rather be done on a background thread. And JProfiler does that with a combination of two more general features. One is request tracking, and the other is exceptional method runs. There are screencasts on both exceptional method runs and on request tracking. You might have a look at them to get more background information on those two general features. Let's look at the session settings of the animated Bezier curve demo. In the filter settings section, there is an exceptional methods tab that contains a single entry here, which is the dispatch method of the invocation event class. This is the method that is eventually called by the AWT framework to process deferred events that have been posted to the event dispatch thread. So what exceptional method recording does is to retain the slowest events separately in the call tree so you can analyze them in detail, isolated from other events. This is the first important feature for analyzing long-running AWT events, and this configuration is added automatically for new sessions, so you don't have to set that up manually. The second important feature for analyzing long-running AWT events can be configured on the session startup dialog. Here you can show the request tracking settings, and the request tracking settings dialog shows you all the various subsystems that JProfiler can handle for request tracking. What's interesting for us here is AWT request tracking. AWT request tracking adds execution sites to the call tree that allow you to jump to the thread and to the call stack where AWT events were posted, so you can find out who is actually responsible for long-running AWT events. And I would rather not like to activate this right now, because if we activate this from the very beginning, we just see lots of events that are related to the initialization of the AWT framework. So we'll activate this later on. So we start the session and we have a look at the call tree, especially the AWT event dispatch thread, and we can see the exceptional method recording in action. The slowest events are shown separately. Actually, those events are not very slow, so the animated Bezier curve demo has a checkbox for simulating long-running tasks on the EDT. Let's select this and look at the call tree, and we can now see the user interface is blocking periodically. It unfavorably impacts the user experience. And indeed, here we can see 300 milliseconds events. Those are unacceptable, and we can now analyze their actions in detail. Here we can see this onEDT method is apparently too slow. Let's look at it in the built-in source code viewer. We can see this is a method that performs some calculations, and this should be done on a background thread. Now we would like to know who posted these events, and that's what request tracking is all about. So let's start request tracking for AWT. We stop CPU recording and start it again just to get a clean call tree without any mixed settings in it. For each of the long-running events, we can now see there is an execution site node at the top that takes us right back to the call site where the event was posted. If I click on this hyperlink, I'll be taken to thread 3 and to this method, which is the culprit for these long-running AWT events. So let's look at the source code viewer, and here we see indeed that there is an invoke later method that calls the onEDT method on the event dispatch thread. So now we have completely localized and analyzed the problem. We can now fix it by pushing this method execution onto a background thread.